Hi students, this is Alex here. In this video they have given a problem. Square plate is bounded by the lines x equal to 0, x equal to a, y equal to 0, y equal to a. Let's take a small diagram. So we take a horizontal axis, x axis, and vertical axis, y axis. So this is our x and this is our y. And we have a square plate which is bounded by, they have given a boundaries. So we take a square plate like this. So these are the boundaries. X is equal to 0 is here. It is the y axis, and x is equal to a is here at a distance a from the origin. And y equal to 0 is the bottom line, that is the x axis, and y equal to a is the top line, which is at a distance a from the origin. And now the square plane bounded by the lines x is equal to 0, y equal to 0, y equal to are kept at 0 degree centigrade. So x equal to 0 is here, and this is u of 0 comma y is 0, and y equal to 0 is here, u of x comma 0 is 0, and y equal to a is here, that is u of x comma a is 0. So all these three kept at 0 degree centigrade. Then the side x is equal to a is kept at 100, and this is u of a comma y, which is 100 for all y ranging from 0 to a, and we have to find u of x comma y. So we're going to write the boundary conditions from the given information. The boundary conditions are number 1, let's write the bottom surface, that is u of x comma 0 is 0, and the second one is top surface, u of x comma a is 0, and the third one left side, u of 0 comma y is 0, and the fourth one, u of a comma y is 100. So here this is for 0 less than y less than a, it is given, and here it is 0 less than x less than a, because x ranging from 0 to a, and even if I take less than or equal to, it is fine. So 0 less than or equal to x less than or equal to a here, and here it is 0 less than or equal to y less than or equal to a. Now we are going to take the two-dimensional heat equation. So the two-dimensional heat equation is dou square u by dou x square plus dou square u by dou y square equal to 0. Now we are going to take a suitable solution for this. The suitable solution is, according to the boundary condition, we take u of x comma y will be, now we have a non-zero value here, so the suitable solution will be a e power px plus b e power minus px into c cos py plus d sin py. Now using the first condition, what are the first condition? U of x comma 0 is 0. So u of x comma 0 is 0. Wherever y is there, we have to substitute 0. So in that case, u of x comma 0 will be a e power px plus b e power minus px into c cos 0 is 1 and sin 0 is 0. So we have only c left, and this value is 0. So 0 equal to a e power px plus b e power minus px into c. Now this a e power px plus b e power minus px not possible to be 0 because it exists for all the values of x. Therefore the only option is c is 0. After getting c as 0, we have to substitute this in our solution. So u of x comma y will be a e power px plus b e power minus px into, when c is 0, we have d sin py along left. We are going to use the second condition. So using the second condition, which is u of x comma a is 0. So u of x comma a is 0. Now wherever y is there, we have to substitute a. So u of x comma a is a e power px plus b e power minus px into d sin pa, and this value is 0, so we take 0 equal to a e power px plus b e power minus px into d sin pa. Already we discussed this a e power px plus b e power minus px is not equal to 0, as this exists for all the values of x, and again d cannot be 0 since already there is a constant 0. The constant c is 0 from the same factor, so again d cannot be 0, then the entire solution will be 0. Therefore the only option is sin pa must be 0. Whenever sin theta is 0, we have the solution theta is n pi. So if I use this pa is like theta, which is equal to n pi. So p is n pi by a. This p value we have to substitute in our solution. So u of x comma y will be a e power px, so n pi by a x plus b e power minus px into d sin n pi by a y. Now we are going to use the third condition. Third condition is the left boundary u of 0 comma y is 0. So the third condition is u of 0 comma y is 0. So let's take it here. U of 0 comma y is 0. So wherever x is there, we have to substitute 0. In that case, this will become u of 0 comma y equal to a e power 0 is 1, then b e power 0 is also 1. So we have only a plus b, and we have d into sin n pi by a y. Now this value is 0, so 0 equal to a plus b into d into sin n pi by a y, and already we know d cannot be 0 since c was 0, and again sin n pi by a y not possible to be 0 because it exists for all the values of y. Therefore a plus b must be 0. From this we can get the value of b as minus a. So using that in our solution, u of x comma y will become a e power n pi by ax plus b, which is minus a e power minus n pi by ax, the whole thing into d sin py. Actually p is n pi by ay. Now we are going to take a common. So a, then e power n pi by ax minus e power minus n pi by ax into d sin n pi by ay. So this is u of x comma y. And now this entire term we can write it as sin h of, that is a hyperbolic function. So this is a into 2 sin h n pi by ax. Then we have d, then we have sin n pi by ay. And the constants 2ad is grouped together. We have sin h n pi by ax into sin n pi by ay. u of x comma y we have, and this constant is together taken as an. So this is an into sin h n pi by a x into sin n pi by a y. So u of x comma y we have. Now we take a general solution using the summation. So summation n is from 1 to infinity. We have an sin h n pi by ax into sin n pi by a y. Now we are going to use the fourth condition. U of a comma y is 100. So here u of a comma y is 100. So using the fourth condition. Now wherever x is there, we have to substitute a. So this will become u of a comma y equal to summation n is from 1 to infinity an sin h n pi by a into a, so it will become sin h n pi because a gets cancelled into sin n pi by a y, and this value is 100. So 100 equal to summation n is from 1 to infinity an sin h n pi into sin n pi by a y. Now we take bn as this constant an into sin h n pi. So finally we get 100 equal to summation n is from 1 to infinity bn sin n pi by a y, and this is the half range Fourier sine series. This is half range Fourier sine series. So we can find the value of bn using the formula 2 by L integral 0 to L. Here instead of f of x we have f of y into sin n pi by a y dy, and f of y is this 100. So and L is a. So in general formula it is n pi by L will come, but L is a here. So 2 by a integral 0 to a 100 into sin n pi by a y into dy. Now when I integrate this, outside we have 200 by a, sin integration is minus cos n pi by a y by n pi by a, and we have limit from 0 to a. Now when I substitute the upper limit, we get minus cos n pi because a gets cancelled divided by n pi by a, and minus when I put the lower limit it will become minus 1, so minus 1 minus 1 plus 1, so 1 by n pi by a. Now we can take the common denominator, so 200 by a n pi by a, we can cancel this, and this can be written as minus of minus 1 whole power n plus 1. Now we have bn, let's write it here. Bn is 200 by n pi, and this one is, we can rewrite 1 minus of minus 1 whole power n, just writing the negative term as a second term. If n is even like 2, 4, 6 dot dot dot, 1 minus minus 1 whole power even number will become positive, so 1 minus 1 it is 0. And suppose if n is odd like 1, 3, 5 dot dot dot, then 1 minus of minus 1 whole power 1, 1 minus of minus 1 plus 1, so it will become 2. So the value of bn becomes 0 when n is even and when this is 2, already there is 200, so 400 by n pi when n is odd. So these are the two values for bn we get. Now substituting that in our solution, u of x comma y is, we have summation bn sin h n pi by a x into sin n pi by a y. Actually, in our solution, we had an. By giving substitution, we get bn. So let's write an here. That is, this is the solution which we had already. Here, u of x comma y is summation n is 1 to infinity an sin h n pi by ax into sin n pi by a y. Now, we will find an from the bn. So what is the relation we had? Bn equal to an into sin h n pi. Let's check it again. So this is the solution. Bn is an into sin h n pi. Now Bn is 0 and 400 n pi we have. So if I take an from here, an is actually Bn by sin h n pi. So this an will become, it is 0 because bn is 0. When I put 0 here, total value is 0 when n is even, and 400 by n pi. So this is 400 by n pi. Along with that we have sin h n pi when n is odd. So we are going to use this an. So u of x comma y will be summation n is from 1 to infinity, but now it exists only for the odd. So instead of 1 to infinity, let's take odd till infinity, and an is 400 by n pi sin h n pi into rest of the terms, sin h n pi by ax, sin h n pi by ax into sin n pi by a y, and the constants can be taken outside. The constants are 400 by pi. Summation n is from odd till infinity. We have 1 by n, and we have sin h n pi in the denominator, and we can take a full denominator, and the rest of the term we can write it in the numerator. That is sin h n pi by ax into sin n pi by a y. And to change this odd to infinity as 1 to infinity, every n is replaced as 2n minus 1. So our final solution is u of x comma y becomes 400 by pi summation n is from 1 to infinity. In numerator, it is sin h of 2n minus 1 pi x by a into sin 2n minus 1 into pi y by a, then whole division 2n minus 1 into sin h 2n minus 1 pi. Thus we got the final solution for the given problem.